Good morning, Alaska. Thanks for joining us. We're delighted to have the opportunity to share with you insights on how you can leverage imagery and 3D mapping to support your work in the rural edge. So we have some excellent speakers lined up today, and they'll provide some context and run through some demos that will be helpful as you begin to roll out the use of imagery in your organizations. So before we begin, we have a couple of administrative points we'd like to first make you aware of. So first, the webinar is being recorded. We will email a link to the recording to everyone that has registered to attend today's session. Second, at the end of each presentation, we're going to have an interactive polling question. So as those pop up, please feel free to select the answer on your screen and we'll share the results with everyone. And finally, we will be responding to your questions today if there's time. So if you have any questions throughout today's session, please use the GoToWebinar app to ask those questions. And again, if there's time at the end, we will respond to those during the webinar. If not, we'll be replying by email. So now I'd like to introduce you to all of our speakers. My name is Noelle Loughran. I am a specialist on the Industry Solutions team here at Esri, and I'll be your host today. Our first presenter will be Tom Sweet. Tom has 25 years of experience working with GIS at the state and local level, to include 15 county COGs within the state of Pennsylvania. He joined Esri in 2012. We also have with us Kurt Schwope from Esri's Imagery Business Development team. He has 30 years of experience in remote sensing technologies and continues to be on the forefront in introducing image processing technology and applications. Kurt will describe the advancements in ArcGIS imagery platform and how the use of drones and raster analytics can significantly improve your organization's productivity. Mark Romero is a solutions engineer on the imagery team, and he will be demonstrating the rich imagery capabilities of ArcGIS 10.5 and Pro. With 13 years of imaging experience, Mark is heavily involved in imagery production quality assurance, driving requirements, and developing imagery solutions. And finally, with us today is Brian Connolly. Brian also is a solutions engineer here at the Esri imagery team, and he'll walk us through some drone to map and LiDAR workflows. Now, before I pass this off to Tom, we want to make sure all of you are aware of the in-person session we will be hosting in Alaska. Dates and location are yet to be announced, but we will have those within the next couple of days. So just stay in touch with your account manager and they'll have all of the details. This is a hands-on session, so you will need to bring your own laptop. We will be providing the software and the demo data sets. We will do a live drone flight on the second day. This is a 2-day program, so we really hope to see all of you there. Now for our very first polling question today. So the question will pop up on your screen momentarily. If I hit the launch button, there we go. And so this is interactive, so please select the answer on the screen. And we'd like to know how familiar you are with using imagery in ArcGIS. So we will give all of you a few moments to respond. All right, thanks for sharing that information. I will go ahead and share those results with everyone. So it looks like most of you have worked with image files doing basic image tasks. So that's really helpful information. Thank you for sharing. Now with that, I will go ahead and pass this on to Tom.
Thank you, Noelle, and thank all of you for joining us today. I'm sure that each of you have your own thoughts regarding what we mean when we say the rural edge. It's a safe assumption that we're talking about that sensitive zone that exists between urban and rural environments. But if you think about it, the rural edge goes much deeper than that. As rural landscapes are transformed, the result is irreversible change that can have significant impact on the quality of life and environment. The key distinction here is that it is irreversible. Think about it. If you tear down a bunch of old houses to develop a modern business complex, are the overall changes really that significant? But what if you cut down a mature forest to make way for an outlet mall? These are irreversible changes that fundamentally change the quality of life within a community. Imagery and remote sensing can be used by GIS professionals to accurately map, visualize, and manage the impact of these changes. The one thing that we all must realize is that the rural edge is not limited to areas surrounding urban or metropolitan centers. Rural edges can be found almost anywhere across the state where development is occurring. Their hallmark, as discussed on the previous slide, is irreversible change that is impacting our environment. These changes are being created by the expansion of our communities, the growth of our recreational activities, and the mechanics of our economy. Another characteristic of the rural edge is that it is a geospatially demanding place. High-impact changes to the land require up-to-date sources of information if GIS is going to be a relevant part of the decision-making process. Furthermore, advanced visualization leads to a better awareness and understanding. In today's webinar and during the workshop, our goal is to show you how imagery and remote sensing can be used to map things like impervious surfaces, the loss of green space, and the overall environmental impact of development. We will investigate remotely sensed sources that can help with developmental projects, GIS updates, and tax assessment. Finally, we will leverage the power of advanced visualization and 3D GIS to improve public outreach, economic development, and decision-making. The velocity of information is never more urgent than when public safety is concerned, whether it be the first response, event security, accident investigation, or full-blown disaster recovery. Remotely sensed imagery is proven to be a primary source for up-to-date situational awareness. Local governments equipped and trained to work with imagery are at a distinct advantage in times of crisis. And while drones are revolutionizing the capture of external geospatial information, very soon this modernization of sensors will turn towards mapping indoors as well. Fundamental to solving the geospatial challenges at the rural edge is a good understanding of the different sources of remotely sensed content. Unfortunately, the volume, velocity, and perceived cost of modern sources of imagery is starting to overwhelm the ability of many smaller GIS organizations to utilize effectively these sources. During the Rural Edge workshop, we will work with many types of remotely sensed data and show which sources are best for the various types of mapping and analysis that government organizations may want to do. We'll especially focus on the types of low-cost imagery readily accessible to GIS departments across the state. Just a few years ago, Esri came to the realization that low-cost commercial drones offered a new window to the world. Before the development of unmanned aerial systems, it had not been cost-effective to use imagery for mapping microgeographies, such as a park, a golf course, or a small development project. With our drone-to-map product and a low-cost commercial drone, small government organizations now have a complete turnkey mapping solution capable of going from raw source data to completed, highly up-to-date information products. Our workshop will help government organizations understand the value of drones and how they can implement a program within their own organization. Another great source of remotely sensed information comes directly from Esri via the Living Atlas. In addition to our up-to-date imagery base maps, we will demonstrate at the workshop how Esri users can freely access and utilize the latest 4-band NAPE imagery from the USDA, or Landsat multispectral imagery from the USGS, and Sentinel-2 imagery from the European Space Agency. One new imagery product, which will be added to the Living Atlas in the next few weeks, was developed by the Maxar Corporation. The National Urban Change Indicator, or NUCI as it's called, is Maxar's innovative commercial urban change detection product, which highlights areas of new construction activity by isolating changes that persist over time. NUCI enables analysts to rapidly identify areas of urban expansion across the landscape of the continental United States by filtering out noise from seasonal, agricultural, and other natural cycles that hamper traditional image-to-image change detection methods. The dataset includes an archive covering nearly 30 years of change. Another great example of a resource that's available to GIS organizations is the detailed land cover of the entire Chesapeake Bay watershed. This was built by the Chesapeake Conservancy from the latest NAPE imagery. This data set categorizes natural, human-made features that exist on the landscape, such as buildings, tree, canopy, impervious surfaces, and water. It is one of the nation's largest high-resolution land-covered data sets available. The data set was created for the Chesapeake Bay program, a regional partnership of EPA, other federal, state, and local agencies, and government nonprofits and academic institutions that lead and direct bay restoration efforts, which was looking to improve its data related to the Chesapeake Bay watershed landscape. Again, it's a great example of what can be done with imagery. As your experience with imagery and remote sensing grows through this webinar and the upcoming workshop, you'll begin to realize just how compelling imagery can be used to tell your story the best. Regardless of whether your information products are shared with a coworker in the office, mobile workers out in the field, decision makers in the boardroom, or keeping your constituency informed, the use of imagery for the creation of story maps and operational dashboards expands the power of your messages in very significant ways. A key part of the workshop will be dedicated to determining how to make your imagery an authoritative source of information that is produced with published accuracy standards. As a result of this effort, any measurements made from this data can be made with legal standing. Traditionally, organizations have had to wait every few years to update their GIS whenever new imagery for their jurisdiction was required. With an effective drone program and the creation of authoritative imagery sources, GIS shops can use their own organic capabilities to update their GIS layers and imagery-based maps whenever they desire. One of the best examples of where imagery plays an important role is in the analysis of the environment to support its management by interested stakeholders. From monitoring community assets like trees, open space, soils, as well as even air quality and temperature, etc., to analyzing their interaction. Perhaps nowhere is it more apparent that we must transform volumes of data to meaningful information to change the discussion from the technology-driven one to one that is focused on the business of governance to manage the challenges. And finally, I think we recognize that it's a 3D world. The modern GIS framework must include the capabilities to empower rich stakeholder conversations to drive decision-making with real three-world dimensional analysis. Another important component of the workshop will be to demonstrate how remote sensing provides authoritative 3D data that supports a wide range of applications in government, including visualization, authoritative reconstruction of accidents and crime scenes, to producing 3D buildings for community and urban planning and other business-centric workflows to drive key decisions relevant to the economic development group, solar planning, flood hazard mitigation, and more. Our growing world faces complex changes, to be sure. To manage these challenges, the GIS framework has evolved to develop our ability to understand these complex relationships. The system of record, the system of insight, and the system of engagement that empowers GIS is the framework used by imagery and remote sensing. This means that imagery and remotely sensed data overlaid directly on top of and are an integral part of the ArcGIS platform. But before Kurt and the rest of the team begin describing and demonstrating the remote sensing capability of the ArcGIS platform in more detail, let's take a look at our next polling question. Noelle, back to you.
Thanks, Tom. And there we go. So everything should be working now. So on to our next polling question, and I will share all of that with you. So as soon as that appears on your screen, please respond with the appropriate answer. This time we'd like to know, how much has your organization migrated to ArcGIS Pro? So we'll give all of you a few moments to respond. All right, thank you for that. So we will share the results. Looks like most of you are moving in that direction, but it's not fully adopted. So that is great information, and it is the perfect segue into our next presentation from Kurt. And Kurt, I will pass this on to you.
Thank you, Noel, and I would like to express my thanks to all of you who joined our webinar today. As Tom highlighted in his presentation, we feel that with all the new remote sensing capabilities now available, that developing an imagery practice within your organization is one of the best things you can do to improve the capabilities of your GIS. In my presentation, we're going to dig deeper into those capabilities to show how easily the power of remote sensing can be used by even the smallest of GIS shops to accomplish big things. By the looks of the polling data, many of you are at least familiar with imagery and its use within ArcGIS. Since I joined Esri 8 years ago, our remote sensing capabilities have greatly expanded. We've reached the point where Esri provides a comprehensive imagery platform capable of supporting all the imagery needs of any state or local government. It all starts with Pro, as it provides the visualization, analytical, and photogrammetric tools needed for any remote sensing practice. So now let's take a closer look at Pro. The reason we recommend it as an imagery solution over ArcMap is the fact that it was built 100% with the use of imagery in mind. ArcGIS Desktop just does not have the processing muscle or graphics capability to effectively work with imagery data quickly or efficiently. Pro has changed all that. Though San Francisco really isn't on the rural edge, let's take a look at this satellite imagery to show you the power of Pro. ArcMap can only display imagery in map coordinate space. For images taken obliquely, like this satellite imagery, and imagery from photometry, working in map coordinate space distorts the buildings with a heavy lean. With the click of a button, Pro can simply switch to image coordinate space. This is the exact same image, but it is being displayed in image coordinate space. Best news is that the computer still maintains all the georeferencing and coordinate information. This means that all of your vector and feature layers fit perfectly over the image. This is because Pro now understands how the different sensors collect the imagery. We've added photogrammetry. Now we can take precise measurements, even in 3D, directly from the imagery. Working in image space and doing 3D measurements is just the start of the visualization capabilities of Pro. For starters, Esri provides massive amount of imagery that you can use for a variety of applications. This content starts with our imagery base maps and expands into USDA NAPE imagery, Landsat, the Sentinel-2 satellite imagery, all from the Living Atlas. It's also easy to add your own content. In this case, freshly collected imagery from FEMA covering the damage caused by a hurricane. Simple image enhancements in the swipe tool provides visual change comparison. Access to current sources of imagery allows you to quickly update your feature service, so you can create a number of information products to include operational dashboards. But Pro is more than just a visualization tool. In the demo, Mark is going to show how easy it is to use the analytical tools of Pro to extract land cover from imagery and use it to calculate the amount of impervious surface associated with each parcel. If your jurisdiction is worried about stormwater runoff, then this is a great way to assess your requirements. Furthermore, once you learn how to extract features from imagery, you can apply the same techniques to any number of applications you may have when mapping your area of interest. Artificial intelligence tools have also been added to improve our feature extraction capabilities. And though this topic will only be lightly covered in our Rural Edge workshop, you can expect to see more and more AI functionality to be added to our platform in upcoming releases. And Pro has all the remote sensing tools needed to support your organization as your image processing skills increase. For instance, in Pro, we introduce a new type of processing capability called Raster functions. These are like GP tools, but they work dynamically, displaying the output information directly to the screen. So rather than clogging your hard drive with a bunch of separate raster files, simply add a raster function to the image and create your own information products on the fly whenever you need them. These raster functions can even be chained together to do complex analysis, all on the fly whenever you open the file. Here's a great example on how you can use raster functions to minimize your storage requirements and make your file management so much easier. In this case, we take elevation data and add raster functions to the source file. From a single file, you can generate these separate information products on the fly with no increase in storage. Just add the appropriate raster function and it's created every time you open the file. Finally, it's important to realize that the image processing functionality of Pro can scale. If you add an image server into your architecture, you can distribute this processing over multiple computers. In this particular case, our customer, the Chesapeake Conservancy, was able to push their Landcover analysis into the image server operating in the cloud. This allowed them to generate 1 meter land cover covering the entire Chesapeake Bay watershed in a fraction of the time than using more traditional remote sensing approaches on single computers. The results were amazing in that they were able to generate highly accurate land cover of a huge area of interest using the NAPE imagery freely available from USDA. So let's take a look at how this scalability works. This is the heart of imagery management, and as the imagery needs of your organization grows, the more important proper imagery management becomes. It starts with our data model for imagery called the Mosaic dataset. The Mosaic dataset works with both Pro and the image server to let you quickly and easily access any image pixel at any time within your entire archive. Notice I didn't say image file. While the Mosaic datasets knows where all your files are and maintains the metadata associated with those files, the modern imagery user just wants to work with the pixels that cover their area of interest. And it doesn't matter if those pixels are from one image or 100 images. All the display and visualization capabilities and all the raster functions of Pro can be applied to Mosaic dataset versus separately processing all the numerous image files that cover your area of interest. Now, some of you may be thinking that you just don't have that much imagery, but if you plan to add a drone capability, a single flight covering a small area of interest can include hundreds of images. Furthermore, this approach can also work with point clouds. So how many of you are planning to work with LiDAR? That's the beauty of the Mosaic dataset. It's designed to work with all types of images taken from all different types of sensors. Aerial, satellite, and now drones are all producing relevant, up-to-date content that you can leverage to improve the capabilities of your GIS and better support your customers. What's more, Esri remains committed to continuously updating the Mosaic dataset so that as new sources of remotely sensed content become available, you'll be able to take advantage of what they have to offer. As you get more sophisticated with the imagery capabilities of your GIS, your next step will be to consider using Imagery Services. Earlier, I talked about how Pro can access different types of imagery from the Living Atlas. Landsat, NAPE, elevation, and Sentinel-2 imagery is all being shared with our users via our Imagery Services capability. But something you should be aware of is that you can build and share your own imagery services using Pro in the image server. As you add more imagery from different sources, whether it be a state collection program or your own drone collections, you may want to share that information across and outside your organization. Imagery Services can do that, and they can be used by a wide variety of capabilities. ArcGIS Pro, new web apps, and specialized story maps can all be used to visualize and even process imagery delivered via Imagery Services. In fact, one of our newest imagery products is Scalable. This thin client application is designed to do basic image processing, such as visual change detection and feature service updates. It's low cost, simple to use, and can be shared across the organization, and it's 100% designed to work with Imagery Services. So before I turn the webinar over to Mark to give a demo of the capabilities of Pro, let's take a quick look at the overall ArcGIS imagery platform. And while this architecture may be overwhelming to some, just remember it all starts with Pro. For some organizations, that's all you need. But for those of you looking to do more with imagery, realize that Pro is just an access point, a start to the platform, a platform built around Imagery Services. The image server, leveraging the power of the Mosaic dataset, can ingest imagery from all types of sources and sensors. Photogrammetry is used to make those sources authoritative for use within your GIS. Analytics can be set to run at scale to extract features from the imagery and do all types of advanced analysis like change detection. Users can access all this content using powerful clients like Pro or easy-to-use web applications like Excalibur. Finally, the platform can display the information needed by decision makers via story maps or operational dashboards. This is what we mean when we say that ArcGIS is a comprehensive imagery platform. Now I will turn the webinar over to Mark, who will dive deeper into some of the capabilities of Pro that I presented. Here you go, Mark.
Thanks, Kurt. I'll begin with an overview of artificial intelligence and how image classification fits into this domain. Artificial intelligence broadly describes how a computer or a machine can do a task that requires some level of human intelligence. One of the engines that makes this possible is machine learning. Machine learning deals with data-driven algorithms or techniques that learn from the data to find the information you need. This portion of the presentation will discuss machine learning. ArcGIS is fully equipped for deep learning workflows, but we won't go into details about this in this presentation. Classification is one type of machine learning built into ArcGIS. Classification of impervious surfaces and land cover are common classification applications with imagery. The techniques for image classification are supervised and unsupervised, pixel or object-based. With unsupervised classification, it is generally used when you're not familiar with the area and no training samples exist. The user identifies the number of classes and which bands to use. The software returns clusters based on similar pixel values. With supervised classification, the user defines the training sites representing the classes. The software uses those training samples and returns the image defined in each of those training sites. With object-based supervised classification, the user is classifying the objects, not the pixels. The objects are generated based on similar color, texture, and tone. Training samples are still collected. Where it is different is that statistics are generated based on spectral, spatial, texture, and shape. Here are the steps to perform an object-oriented classification workflow. First, is to obtain the right image. Next, we perform image segmentation, where the image is clustered or grouped into objects. We then train the segmented image by creating classes that define the land cover type. In the fourth step, we generate the classified image, merge the classes. In this case, we merge all the impervious land cover types into one and generate the result. For the object-based classification, you'll need ArcGIS Pro 2.1 or greater, or ArcMap 10.3.1 or greater, with the Image Analyst extension. ArcGIS Pro is a fully functional image analyst workstation for performing classification. It also includes a wizard for stepping through the classified workflow. In Pro, you can utilize multiple monitors and dock all the necessary tools that you'll need to perform classification and extraction. In this software demonstration, I'll use ArcGIS Pro to identify impervious surfaces like roads, roofs, and sidewalks. Many local government institutions use impervious surfaces to calculate the stormwater bill for a property. We'll be using an object-oriented feature extraction method and the ArcGIS Pro classification tools to accomplish this. This 4-band multispectral image just outside of Louisville, Kentucky is ideal for performing detailed feature extraction of impervious surfaces. It's a 6-inch resolution aerial photograph and contains a near-infrared band. An important step for extracting features is exploring the imagery. We can change the band combination of the image to highlight certain features like vegetation and roads. A color infrared band combination makes it easy to pick out the vegetated areas in this neighborhood. Products can be created using built-in indices to enhance differences between bands. In this case, I can choose NDVI to identify healthy vegetation. The histogram within the NDVI image can be created to show the frequency and distribution of pixel values. The histogram also helps identify anomalies. We can see the low pixel value of -1 and the max, and where most of the pixels fall along the histogram. Now that knowledge of the pixels have been identified, how can I discover which of those pixels represent healthy vegetation? Using the NDVI as input, a raster function called the remap can be applied to extract pixels representing healthy vegetation of -1 to 0.20 are remapped as no data, and values greater than 0.20 are given a value of 1, returning a binary raster that approximately represents healthy vegetation in the map. We can later use those as training samples in the classification process. Another exploration tool in Pro is the scatter plot. This can be used to visualize the relationship between two bands. The entire range of pixel values for the red band is plotted on the x-axis and the near-infrared band on the y-axis. I can interactively select the pixels to learn where the thresholds are for each feature. This allows me to quickly identify features such as impervious surfaces and where those thresholds are. I can then plot the range of each threshold, save those, and use them later on in my analysis. To perform classification, users can decide to run each step manually or through a wizard in Pro. Within the wizard, I can choose the classification method, supervised or unsupervised, object or pixel based. If I have a classification schema, I can select that. If I've done segmentation, I can choose the segmentation image or skip it. And if I've collected training samples, I can also choose to input those into the wizard. The first step in my scenario is to perform segmentation. Segmentation is the process where pixels in close proximity and having similar spectral characteristics are grouped together into a segment. Segments exhibiting certain shapes and spectral and spatial characteristics can be further grouped into objects. I can compare the segmented image to the aerial photograph to identify the spatial, spectral, and minimum segment size values that I've chosen. If I need to go back and adjust those values, I can do that directly in the wizard. I can also choose to view just the vectors as polylines. If I turn off the image, you can see how much detail I've collected over this particular area. Next is the training sample collection process. The training sample manager streamlines the process by letting us quickly select the objects. I can choose some different objects within my classification schema, such as vegetation, impervious surfaces like sidewalks, and roads. And I could group those and then continue on with the wizard. Next, using support vector machine, I train the image, generate the classified raster, and then I can group those different classes into two classes which represent impervious and pervious. And finally, I get my result shown in the map. As I further explore the result, I notice there's some misclassified pixels. At Pro 2.4, I can use the new pixel editor tool to add, delete, or reclassify pixels in the classified layer. Here, I'm adding misidentified pixels by directly editing the layer in the map. That concludes the demonstration. I'll hand it back to Noel.
Thanks, Mark. Now, before I pass this off to Kurt again, we want to show the third and final polling question. So as soon as that appears on your screen, please feel free to provide one of your answers. The question this time is, does your organization have a plan to use drones? And again, we'll give you a few moments to provide us with your answers. And thank you. We will go ahead and share those results. So it looks like you, or most of you, are interested, but nothing planned yet. So that is great information. Thank you. And I will go ahead and pass this back off to Kurt so he can talk to us a little bit about drones. So Kurt, it's all you.
Thanks, Noel. That polling data is real informative, and I'm glad to see all the interest in drones by our audience. In my first presentation, I talked about Pro and how photogrammetry is being used to make authoritative imagery for updating GIS. During the workshop, which I encourage you to attend, we'll dig deeper into the photogrammetric capabilities in Pro. But most of you will likely get your imagery already orthorectified and ready to go, unless, of course, you want to work with drones. So while the photogrammetric capabilities are built more for satellite and aerial imagery, we have Drone to Map and our new Enterprise UAS capability designed to work with this exciting new source of content for your GIS. And frankly, it's pretty impressive what these low-cost software additions can do. Drone to Map is one of the fastest selling applications that Esri has ever released. It has a proven track record used by many different types of users to create imagery products for their GIS. In this example, our customer, Will Short, collected and processed 4,800 images covering a small airport in southwestern Virginia. The result was a very high-resolution 3D scene layer used by the local municipality and associated planners to better understand how a proposed expansion to the airfield would impact the surrounding region. Over the course of 3 days, Will was able to collect and process the area of interest. He figured out that to pay an aerial firm to do the same work would have cost about 3 times the expense of his drone, as well as the software and his labor. At some point, there's a break-even cost, but for smaller microgeographies, drones are a fantastic way to collect fresh imagery of locations valued by your organization. Most commercial drones are capable of making 3 categories of products. The first is 2D image maps. These are map-accurate orthophotos seamlessly stitched into an image base map. This category also includes digital surface models and bare earth digital elevation models. The second category is 3D elevation products, which includes 3D point clouds in the LAS format and 3D mesh models, which are suitable for site modeling. The third category are inspection photos. These oblique photos of a specific target that can be used for maintenance evaluation and basic measurement of objects within the image. When you dig deeper into each of these product families, you can see the types of derived imagery products easily created with drones. Orthophotos, detailed digital surface models, and point clouds can all be used to create additional information products like updated high-resolution base maps, zoning decision aids, and stormwater management products. 3D site models can be used for planning, viewshed analysis, and even economic development. Inspect and measure capabilities can be used for asset management, property maintenance, and maybe even tax assessment. Literally, with the addition of drones to your GIS, the sky is the limit on potential applications. And drones are pretty straightforward to fly. They are literally aerial robots. Users simply determine what type of flight pattern is best suited to collect the imagery needed for the type of information products desired. Use flight management software to designate your area of interest, upload your collection pattern, then set the drone free to do its work. We'll actually go through all these steps during our workshop, just to show you how easy this really is. So, this is actually a video of drone to map being used to process imagery to create a site model. The collection covers a statue in Richmond, Virginia of Robert E. Lee. As you're probably aware, there has been some controversy regarding these Confederate statues located in prominent parks within many southern cities. Richmond Park Authority wasn't sure what was going to happen, but they did know they wanted very high-resolution imagery of all their parks and statues to help with the planning. Using a drone in the Drone to Map software, in a matter of weeks, they were able to collect and create very detailed site models of all their statues. And while the controversy remains, at least the city of Richmond now has detailed information that they can use to better assist how they are going to transform these sites to meet the concerns of their constituency. While Drone to Map has tremendous capabilities, we began to hear from our users that they wanted more. Drone to Map does not include a native flight management capability, but we all know that it's an important first step. While the most recent release of Drone to Map has seen significant speed increases, some projects are simply too big to be easily processed on PCs found in many government organizations. Our Drone to Map customers also really value the 3D products for use in analytics and site modeling, so improving and shortening the time to create these products is highly desired. In short, our customers were looking for a powerful but simple solution that could support enterprise-level activity. They simply wanted to upload their imagery into the cloud, press a button, and use the resulting output with all their favorite ArcGIS apps. So, we developed our Enterprise UAS capability. Today, we are providing a sneak peek at this new software as a solution that we plan to release in the fourth quarter of 2019. This subscription-based SaaS offering will totally scale to meet the needs of organizations with multiple drones collecting volumes of imagery. For some organizations, with just 2 or 3 drones, maybe drone to map is all you need. But for larger jurisdictions or state agencies wanting to expand their use of drones for 3D mapping, we highly encourage you to take a look at this new capability. From this new SaaS solution, we now have a brand new flight management capability to assist you with properly collecting your imagery for the type of project you are planning. It works with both drone to map and UAS Enterprise to make your flight planning activities easy. Built by our strategic partner 3DR, the Esri Site Scan Edition can be downloaded from the Esri Marketplace. It can connect directly to your ArcGIS Online account and use your own saved maps as base maps for the flight planning process. Tightly integrated with our platform, the Esri Site Scan Edition is the ideal way to control your drone in a way that ensures the images you collect work well for your GIS needs. So while we are still working on the final implementation of the Enterprise UAS capability, here's a sample project we completed using this new solution. In this product, the source of the imagery was actually a low-cost camera mounted on a small plane being flown by the Civil Air Patrol following Hurricane Michael. The pilot was flying the plane in a similar altitude and speed that drones can operate, so we could actually use both drone to map and Enterprise UAS for the processing. I think the results speak for themselves. In addition to the orthos that I showed in my first presentation, here are the point clouds generated from the imagery. The system was able to quickly produce high-resolution point clouds of the entire area of interest. Using Pro, these point clouds were transformed into scene layer packages for display in ArcGIS Online. The resolution of the point cloud shows the tremendous detail of the devastation. These output products are suitable for doing change detection to identify the extent of the damage, and for using analytics to calculate the total volume of debris that needs removing. But drones and the point clouds you can create from the imagery are just one basic collection strategy. High-resolution LiDAR collected by laser scanners continues to grow in popularity as a source of geospatial information. These scanners can be mounted on all types of platforms. In addition to aircraft, LiDARs are being mounted on cars, boats, and trains for mobile collection. Terrestrial LiDARs mounted on tripods are ideal for detailed site planning. LiDARs can even be mounted on backpacks for collecting point clouds inside of buildings and other enclosed spaces. The best news is that recent additions for ArcGIS Pro allow you to work with all these different sources of point clouds. What has changed is that we have optimized the data model we were using to manage and process point clouds. In the past, we were restricted to working with point clouds that had been stored within a last data set. Users are no longer confined to this practice. In fact, with ArcGIS Pro, you can simply drag and drop your last file into the viewer and immediately visualize the point cloud and run analytics against the data. Because we've optimized viewer memory management, Pro doesn't suffer from painful slowdowns when working with very large point clouds. What's more, we have developed a set of best practices to handle large collections of LAS files, just like we manage large collections of imagery using the Mosaic dataset. Finally, the most exciting capability is that you can take all your 3D data, to include point clouds, and publish them as scene layer packages. These in turn can be displayed and worked with in ArcGIS Online using your favorite web browser. In addition to LAS file management, a number of new LiDAR processing tools in Pro allow you to classify and transform raw point clouds into GIS feature information. We are going to shortly show you how this is done in the upcoming demo. And during the workshop, we will teach you and your team how to use these tools to extract building footprints and create 3D feature layers of both structures and vegetation for your GIS. In summary, Here's just a few examples of applications and use cases for using LiDAR within ArcGIS. During the workshop, we will investigate the various workflows needed to convert raw LiDAR point clouds into a variety of these useful information products. I'm now turning the webinar over to Brian Conley, who will demonstrate both the power of Drone to Map and how to work with last point clouds inside of ArcGIS Pro. Take it away, Brian.
Thanks, Kurt. I'm going to demonstrate our newest version of our standalone drone processing application, Drone to Map. Drone to Map has one job. It takes photos collected from a sensor on a drone and processes both 2D and 3D GIS-ready products. When you start Drone to Map, you begin on the project template screen, where you can select from a few different pre-configured templates, each designed for a specific workflow. For example, the 2D Rapid allows you to create low-resolution orthomosaics and elevation models, allowing you to quickly assess the results of your data collection effort. The 2D Full allows you to create full-resolution orthomosaics, elevation models, as well as multispectral imagery, depending on the sensor you're using. 3D Mapping is set up to create 3D products like point clouds and 3D meshes. It's important to note that you can completely customize these templates to fit your needs. Starting a project is easy. Just give it a name, an output location, and then add your images. Images collected from most drones today also capture latitude, longitude, and altitude, or the height above ground that the image was taken. It's good to verify these data are consistent with your flight plan. Once your project is created, Drone to Map displays your flight data in the map area. The image center points are displayed by the blue icon, and the flight line is shown as an orange line. You can inspect your images immediately by accessing the Flight Data ribbon and selecting the Image Viewer. This gives you the ability to cycle through the images to inspect each file. Change the image in the viewer by just selecting the icon or scrolling through the Image Viewer window. When you're signed into your ArcGIS Online account, you have full access to all the Esri base maps, such as the World Imagery Base Layer, so that you can compare the orthomosaic to the existing imagery. This new version of Drone to Map has improved ways to interact with ground control data. Displayed as the green crosses, ground control is vital for GIS users, especially surveyors and engineers, allowing them to create accurate GIS-ready products. To ensure your project is accurate, you can now set ground control targets as checkpoints. This allows you to set aside control points to be used later in an accuracy assessment. These results appear in the processing report generated after you process a job. To begin processing a job, just hit the Start button and Drone to Map will do its thing. It'll first match key points between images so that you can generate the outputs. This step uses principles of structure from motion to stitch all the images together. Depending on how many images you have in your project, this process could take some time. So let's just go ahead and move over to a completed project to see some of the products you create with Drone to Map. Zooming in, we can see how the orthomosaic looks relative to the World Imagery Base Map. Drone to Map runs on the Pix4D framework and uses similar algorithms to stitch together drone imagery. Because this project established ground control, the orthomosaic aligns nicely with the imagery base map. Also generated were digital elevation models. Here I'm showing the shaded relief for the digital surface model. Drone to Map also generates bare earth terrain models that can be used as a localized ground elevation surface. I set this project up to create contours at 5-foot intervals. You can set any interval you'd like when setting up your project. It also generated a point cloud. I'll show this point cloud again in 3D. First, I wanted to demo a few of the basic analysis tools within Drone to Map. The analysis tools can be accessed through the Analysis ribbon, allowing you to measure distance, area, and volume within your project. Simply select the measurement tool you'd like to use and interact with the main screen to begin the measurement. These are all stored for later use. Let's move over to the 3D map to view the 3D products that were generated. Here's that point cloud again in 3D. The point cloud can be rendered as elevation as shown here, classification with its RGB value, and so on. Bringing these data into ArcGIS Pro opens more possibilities of working with the point cloud. I'll be demoing some of those capabilities next in the next demo. We also created a 3D textured mesh. However, because this project was flown for surveying purposes, the mesh didn't do a great job capturing the sides of these buildings. Let's jump over to a project that was set up for 3D analysis so you could see the results. Immediately, you can see how the flight plan was set up to capture data in an orbital pattern at 3 different altitudes. This is the best practice for flight planning a 3D job. Zooming in, we can see how this 3D mesh looks compared to the previous example. The sides of the structure are photorealistic, and that's because we made sure the camera took images at oblique angles so that the sides of the buildings are captured well. All of the data created within Drone to Map can easily be shared to your ArcGIS Online account or portal by selecting the Share ribbon. Once the data are hosted, we can then share these data within our organization and create web maps that allow us to take advantage of basic web analysis tools in ArcGIS Online, such as this measure tool. Here I'm measuring the height of this building. Next, I'll measure the area and its perimeter. Here's another project that we flew for both 2D and 3D. This is actually the building I'm currently in. It's the Esri Denver Regional Office. Using ArcGIS Online configurable applications, we can create online tools to help analyze your drone data. For example, this 2D map shows the Denver office with a swipe tool. It's currently set up to compare the hillshade elevation model with the orthomosaic. You can imagine how these tools can be used to easily compare imagery of different types and collection dates. It's important to note this application was created completely out of the box. No custom coding was used. But you could also take advantage of the JavaScript API to completely customize applications to fit your needs. This wraps up my Drone to Map demonstration. Next, I'm going to show you how to take some of this 3D data to the next level using ArcGIS Pro. This demo will show ways of working with LiDAR data in ArcGIS. The goal of the demo is to give you some ideas for maximizing the use of your LiDAR data, how to manage it, perform analytics with it, and extract information from it. For many users who have LiDAR data, the end goal is to generate derivative products. Here's an example of building footprints that can be extracted from the classified LiDAR. You could also derive elevation products. Here, I'm comparing the DTM, representing the bare earth surface, with the DSM, or everything above ground. High-resolution surface models like these are important for change detection, hydrologic analyses, engineering projects, and so on. Using these derived products, we can create a 3D representation of buildings, trees, and other features, allowing us to use LiDAR data to model an entire city or town in 3D. To generate some of these products, we first need to organize and manage LiDAR data. Then we can inspect the data and begin our analyses. ArcGIS Pro is the tool for these workflows. In ArcGIS Pro, you can work directly with the raw LAS file. Here I have LiDAR data collected over a rural area. These data were collected in 2012 by Dewberry and downloaded from 3dep. You can begin visualizing your LiDAR data using different renderings to display returns as elevation, classification, surface models, and so on. If you have more than one LAS file, you can load multiple files into a data model we call the LAS dataset. Creating a LAS dataset is straightforward. I right-click on a folder, create a new LAS dataset, give it a name, and then add the LAS files. Once the LiDAR data is added to the LAS dataset, you can immediately view various statistics and other important information about your LiDAR data, such as its classification schema, point spacing, the LAS version, and so on. I'll go ahead and add the LAS dataset into the map to begin working with it. The extent of the LAS dataset is seen here with each red square representing each LAS file. With the LAS dataset, we can start to work with all of our LAS files simultaneously. In this next part of the demo, I'll walk through the classification process. LiDAR you download from sources like 3dep are often already classified for noise and ground, but sometimes you start with LiDAR data that looks just like this, where the gray points represent unclassified returns. In ArcGIS Pro, there are several automated classification tools that help you classify your data to create a product like the one shown here, where all of your LiDAR returns are classified according to ASPR's LiDAR classification standards. All of the classification tools can be accessed from the classification ribbon. For the sake of this demo, I'll go ahead and speed through this process. I'll begin classifying ground points. There are tools to help classify noise and overlap so you can clean up unwanted points. Next, we'll classify the buildings and then the trees. You can use predefined features to help us classify point clouds. So if you have access to planimetric data such as road surfaces, building footprints, you can use these features to help you classify your LiDAR data. Switching to 3D allows you to easily visualize and inspect how the classification process is going. The automated tools are never perfect. Sometimes you may need to go back and manually classify certain features. For example, this bridge deck was incorrectly identified as a building. We could use the manual classification tool to select specific points to classify. You'll notice I accidentally selected some ground points in this process. If I were to use the profile tool instead, this will help me isolate a cross-section of the points to ensure that only the returns I want to be considered a bridge deck are classified as such. Earlier, we mentioned that we now have tools to colorize your LAS files. It's best when you have imagery collecting at the same time as the LiDAR data was collected, but that's not always possible. So here, I'll be colorizing the LiDAR data with the most recent NAPE data. The geoprocessing tool for colorized LAS allows you to select any image to use to colorize the point cloud. But like I said, the closer in time the image and LiDAR data are collected, the better your results will be. That's because construction or other things could happen in that time period between. Colorizing your LAS lets you immediately see a realistic 3D representation of your area of interest. All right, switching gears now, I'll show you how to begin creating some surface models. Once your LiDAR data is classified, you can create specific surface products by using the LAS dataset to Raster geoprocessing tool. For example, I'll first use the tool to create a digital surface model, or DSM. We can then filter our LAS dataset by using the LAS filter to turn off everything but the ground class and last returns. Doing this step isolates only those returns, so that when we run the tool again, we can now create a digital terrain model, or bare earth surface. Once we have these two surface models created, we can use a bunch of other image analysis tools within ArcGIS Pro to begin analyzing our elevation data. For instance, we could use raster functions within the imagery ribbon. These allow us to generate on-the-fly products such as hillshades, slopes, aspects, contours. We could do things like raster math and so on. Here, I'll be creating a hillshade representation for our DSM and DTM surface models on the fly by using the raster functions. If I were to manage these data in a mosaic dataset, I can apply these raster functions as processing templates, and then I could share these elevation models and their derivative products out with my organization. In this next part of the demo, I'll show you how to use feature extraction solutions to generate realistic 3D buildings and vegetation over an entire city or town. The first requirement to do so is to create building footprints. Now you can extract these footprints from the classified LiDAR, but before you go off and create them yourselves, I suggest researching what might already be publicly available. For example, many state and local governments around the world have open GIS data websites where you can download freely available and authoritative data. This was very helpful in helping me process some of the LiDAR data that I was showing so far. Another source you may check is the Microsoft Building Footprints dataset, which contains over 125 million computer-generated building footprints for the entire US. We've added these footprints to ArcGIS Online as a feature layer and as a tile cache, and made them available to our users. As I zoom in, you'll be able to see the buildings appear and see how extensive this dataset is. It's a real time saver when working with LiDAR. Or if you want to generate your own building footprints from your own LiDAR data, you can come to our workshop. We can show you how to do it. You can use our solutions to extract building footprints, generate 3D buildings, and then publish all these data to your ArcGIS Online or portal account. We do this using the local government's 3D base map ArcGIS solution. Accessing this workflow, you'll use a series of tasks to take you through the entire process, from creating LAS datasets to classifying, generating 3D buildings and trees, and then publishing the data to the web. This workflow is great for local governments to create specialized base maps or 3D models to help with city planning. Speaking of city planning, I just want to mention a new ArcGIS product called ArcGIS Urban. This tool is a great way to take your 3D data to the next level. It allows users to combine a 3D scene like the one I've been showing with demographic data. For example, you could apply indicators like population change to aid in city development plans. This tool gives city planners a way to understand how their development plans will impact their city. This wraps up my demo. I hope it inspired you to find new ways to work with your LiDAR data. Back to you, Noelle.
Thanks, Brian. So we are running a little over, so we apologize, everyone. We won't be able to get to questions. But before we leave you, we wanted to let you know that we do have some great news. While on this session, we were able to confirm the date and location for our upcoming workshop. So our imagery team will be at the Anchorage City Hall, October 29th and 30th. We do require advanced registration for this, so we will provide a link for the registration page when we send a link of the recording out to all of you. So thank you very much for everyone joining us today, and thanks to all of our speakers, and we look forward to seeing all of you in Anchorage in October. Thanks for joining us. Bye.